to 0, right, in these two different cases. So this integral, sometimes it converges, sometimes it diverges. What happens when p equals to 1? See, because this is really p greater than 1, excuse me, p less than 1, can't do math, and this over here is p greater than 1. What about when it's equal to 1? What happens? It blows up. All right. So in other words, we have the following result. The integral of dx over x to the p from 1 to infinity equals to infinity if p is less than or equal to 1, and it converges to 1 over p minus 1 if p is greater than 1. So this is a very nice result to know because we can use this to compare to other integrals, all right? So one of the ones we went to earlier, the integral from 1 to infinity of dx over x, 1 plus x to the fourth, right? What do you think? I mean, do you want to calculate this directly? You know, any quartic factors, right? Any real polynomial can be written as a product of irreducible quadratics and linears possibly repeated, which means that can be factored into a pair of irreducible quadratics, in fact. Can you factor 1 plus x to the fourth into a pair of quadratics and then do the, what we need to do? Partial fractions to split that up into two pieces, do those two integrals, each one of them is an arctangent. You start thinking through that, each one of them is an arctangent. It stands to reason that if you did enough calculation, you'd be able to show that it converges. How do I know that that factors into a pair of quadratics, by the way? What does it mean if there's a linear factor in a polynomial? If I have f of x is x minus a times g of x, what's that tell you about a with respect to f? F of a is what? Zero, right? So the fact that 1 plus x to the fourth has no zero, there's no real solution to that, means that if you factor it, it must factor into a pair of irreducible quadratics. Them's your only choices. Anyway, this is all very complicated, what I'm saying. Is there an easier way? Yes. 1 over 1 plus x to the fourth is what? This is less than or equal to 1 over x to the fourth for x greater than or equal to 1. I'm going to spend almost all of next class talking about this issue because you guys need to think long and hard about comparison of functions, all right? It's not an easy topic, but this is the final thing in this section, is to use the comparison theorem to determine convergence or divergence of integrals without actually calculating them. Instead, look for a function which is near to it. In this case, x to the fourth is larger, right? It's larger than 1 over 1 plus x to the fourth. So that means that this is less than or equal to the integral from 1 to infinity of dx over x to the fourth, which is what? By the theorem right above, this is equal to what? 3. 1/3. So by the comparison theorem, I can tell you that the integral from 1 to infinity of dx over 1 plus x to the fourth is at most 1/3. So it's between 0 and 1/3, and it converges. By comparison theorem, the integral from 1 to infinity of dx over 1 plus x to the fourth is converges. And I can also tell you that its value is between 0 and 1/3. So now the game becomes, given an improper integral, can you find a function which is related to it, but is easy to integrate? Because if you can find that, and you can integrate that easy function, then you can decide whether or not the given more complicated function actually has a convergent or divergent integral. So this is a new game. We haven't played this game before, but we'll start playing it more tomorrow, okay? Thanks, guys. I'm sorry I don't have your test back yet. I try to get things graded faster than I am right now.